All right, let's start talking about the next thing you're supposed to do, which is homework. And that's a weak link for a lot of people. They believe they don't need to do homework, or they only do homework if someone's watching them. And that's not what you want to be doing, all right? So I'm going to go through the problems as if I were doing the homework. And what I want to do is, it says over here, consider the following function. And it says show f of x is invertible. And this says by finding its inverse. I'm going to say, show f of x inverse by finding its inverse. It's not really a way to find its invertible, but let's just go with it. And someone says, what do you do over here? Well, let's go through the steps. The first step is to write down f of x as y. I'll write this over here for you. And then it's going to be x minus 2 over x plus 2. And my next step is to change the x and the y. So it's going to be x equals y minus 2 and y plus 2. And now I'm going to make some attempt to solve for y. And what do you get? Let's write this down. xy plus 2x. I'm multiplying both sides by y plus 2, by the way. And then you get y minus 2. And I'm going to make some attempt to solve for y. And again, there's kind of many ways to do it, but let's write this over here. I'm going to write down 2x plus 2 equals y minus xy. All right, and then I'm going to, let's see, I guess I'm going to factor y out, right? So 2x plus 2. And what do you get there? Y and 1 minus x. And I think I can solve for y. What's y going to be equal to? Well, it's going to be 2 times x plus 1. And I'm going to divide it by 1 minus x. All right, let me put the domain down for this. The domain of this thing is all real numbers, except minus 2. The range is more difficult to do, but it's really not that bad to do. But I want to, talk about another way of doing it. And the way I'm going to do that is I'm going to talk about the inverse now. And the inverse, according to me, if I didn't do any mistakes, we'll look at the key later. That's the inverse. So what's the domain of this guy over here? Well, that's pretty simple. The domain of this is going to be all real numbers. X cannot be 1. What's the range of this guy over here? Well, let's take a look at it. I'll be honest with you, it's easy because I'm looking at this. I got it. And what's that going to be? All real numbers. Now, I realize you want to say x not equal to minus 2, but it's f of x. I should say f inverse, sorry about that, is not equal to minus 2. Now, let's put the other one down. The other one's also easy to put down. I'll tell you why, because I know this. Let's write this down. It's all real numbers, and f of x cannot be equal to 1. All right, let's look and see if we got it right. And mistakes happen, by the way. And I want to point out if a mistake happens, I want to rectify it. So let's see, did I get the inverse? And I'm looking at it over here. I got 2x plus 2. Yeah, I got it. By the way, notice they didn't put down domain and range, by the way. And, oh, yeah, they do, right over here. What's the domain of f? Let's see if I wrote that down. Yep, I wrote that down. What's the range of f? Let's see if I wrote that down. Wait a second, I got to look at that again. Oh, I'm sorry. I thought it was the range of f inverse. Yeah, I got that written down as well. We got that one. And then the domain of f inverse. Let's look back over it. Yeah, all real is x not equal to 1. And the range of it, or the other guy. Yeah, we got them all down. All right, let's do this one over here. And this was determine the domain of this function over here. And this is a little complicated, isn't it? But I'm going to rewrite it maybe. And what do you get a domain? It's a 6th root of x. That's what that means. Well, that's an even root, so x must be greater than or equal to 0. So the domain of this problem over here is from 0 off to infinity. That's a domain. Let's see if we got the right answer. Well, right over here. Now again, I wrote in intervals, but this is also fine to write that down. Find the equation of a line with the description slope is 4, y-intercept is 2. Well, m is 4, and if the y-intercept is 2, it means b is 2. You could also use the point 0, 2 if you like. Well, what's this going to be? Y equals mx. That's going to be 4x plus b, which is 2. Got that right over there. This one says, consider the following hyperbola. They give it to me. They also give me a graph, which is great news for me because it makes it so much easier when you do the problem. I wonder what the questions are going to be, though. The question is find a center. Well, the center of this thing is really easy to look at it. The center of this thing is going to be minus 3 for x and 1 for y. And I'm going to look at that, and that's the center of this thing over here. So minus 3, 1. And I'm glad it gave me a picture. Also gave me an answer. Now, what are the vertices? That's a little more difficult, isn't it? But I got to get the picture really helps me a great deal. And let's just take a look at it. I probably set y to be 1. I want to tell you why that is. If I do that, this term disappears. And then the question is, what would x have to be? Well, it's got to be a number 1 squared equals 25 because it would be equal to 1 then. And that could be 2. And there's another number. And that could be what? I'm going to say minus 8. Let me put those points down for you. And that's going to be 2, 1. You notice there's no numbers on these number lines, so I'm just writing these numbers down for you. This point over here is minus 8, 1. Now, by the way, could I make a mistake? Of course. Let's take a look. They got minus 8, 1. Did I get that? Yep. And they got 2, 1. I feel pretty good about that. All right? Now, next thing over here, I'll kind of read it to you. It says find the foci. So I'm going to write this down for you, the foci, and I got the picture over here. So c squared is going to be the sum of these two numbers over here. It's 25 plus 16, and that's going to be 41, right? So what's equal to? Plus or minus root 41. I'm just going to put root 41 because we're going to move in. We're going to move in from the center to get this focus over here. This is a focus. This is also a focus over here. And again, we'll look at the key later. Now, what's nice about that? I know the y-coordinate immediately. It's 1. But I got to move in. So it's minus 3 plus root 41. That's to the right. And this guy's over here. Again, I know the y-coordinate's 1. And it's going to be minus 3. And I'm moving left, minus root 41. Let's take a look, see if we got the right answer. Mistakes happen. And I'm seeing that. Okay? Find the asymptotes. A little more complicated, but I see them. And I'm going to go through that with you. And what I'm going to claim over here is that the way your teachers might have done it in math, I should write the numbers down for you, what courses these are from. All right, sorry about that. Number 1 is a Math 119 question. And again, we have extensive notes for you to look over if you want. Number 2 is a Math 119 question. Number 3 is a Math 100 question. And number 4 is a Math 120. Okay? Now, your teachers, when you took Math 120, they might have explained it to you differently, but asymptotic behavior is when x and y are going towards infinity or to minus infinity. Now, what I'm saying over here, what I know about them is that these guys, when they get really large, they differ by 1. But I'm going to say differing by 1 when numbers are really large, they're roughly equal. So I'd write this down over here. If they're roughly equal, I'm saying x plus 3 squared over 25 looks like this. When x and y get really large, by the way, they have to look equal. I mean, they're huge numbers, but they differ by 1, so they basically look the same. And then what do I do? Well, I got to kind of solve that. I'll write that down for you. So I'm going to write down y minus 1 squared equals 16 over 25 x plus 3. And I'm going to write down y minus 1. I'm using the square root rule, plus or minus 4/5 x plus 3. So I'm going to write down this asymptote here. What's that going to be? Y minus 1. That has a positive slope, which is 4/5 x plus 3. We'll look at the key later. And this one has negative slope. And it's an asymptote, y equals, let's see. I'm sorry, I didn't mean to put y equals because it's not written that way. Y minus 1 equals minus 4/5. It's negative slope, x plus 3. Well, let's look at our key. And I see that right over here. All right, y minus 1, and then the x plus 3 business, right? It doesn't look like a 3. Make it a better looking 3. All right, we got them both. All right, write an algebraic expression that's equivalent to. Boy, let's take a look at that. I want to point out the way your teachers taught you in Math 120. They said this was theta. Let's write this down, a triangle. And let's see, x minus 1 over 1. Because it's sine, right? So let's take a look at that. Let's do this over here. What's it going to be? What's going to be the root of 1 minus x minus 1 squared? I got to figure that out, don't I? Let's see what you get over here. 1 minus, well, x minus 1 squared is going to be x squared minus 2x plus 1. And what do you get over there? Let's put this down. You're going to get 2x minus x squared. Right, pretty simple. Now, what do they want the secant? Well, secant is really the reciprocal of cosine. And so reciprocal of cosine would be this over that, but the reciprocal would be, it would be this. It would be 1 over this. Let me just check again. So cosine would be this over this. So it's reciprocal. That looks pretty easy. And I see the answer right over here. All right, there's some subtle things we haven't discussed about this, but they're really written to work nicely, by the way. All right. So what I mean by that, the sine function, the invertible region of sine function looks like this. Right, and the secant function, well, that's the reciprocal of the cosine function, looks like this over here. And what I know about that, it certainly stands to reason. We got a positive thing over here. Stands to reason. We're getting that. All right, let's look at number 21. This is a Math 120 question. It says a ramp that's 21 feet in length rises to a loading platform that's 5 feet off the ground. So I'm going to do a picture of that. And this is 5 feet off the ground. And then there's a ramp, and that ramp is 21 feet long. All right? What's their question? You know, assuming the ground is level. That's my picture, by the way. They want to know what the angle is. All right, let's write this down. So I'm going to say sine of theta is equal to 5 over 21. So I'm going to say theta is equal to arc sine of 5 over 21. Now, this is an exam question. That's all we'd expect from you. But if you have a calculator and you're at home, you should use your calculator to compute the value there. And it's going to be approximately 14 degrees. But again, that answer is acceptable on exams, the arc sine of 5 over 21. This one says write in summation notation. I'll write that down for you. Summation looks like this over here. And this is Math 120. And what does that look like? Well, I'm looking at it. I notice these things look like powers of 3. So this is 3 to the first power. This is 3 to the second power, 3 to the third power, and 3 to the fourth power. Yada, yada, yada. And I wonder what this is going to go over here. It's 3 to some power, right? Well, we got to figure that out, don't we? So 3, I'm going to put the letter J here. I'm going to say J starts at 1, but I don't know where it stops, by the way. So I'm going to put this over here. What's 3 to the fifth power? That's 243. What's 3 to the sixth power? A little more difficult. So write this down. 3 times 243 now, right? That's going to be 9. 3 times 4 is 12, right? 3 times 2 is 6, 729. So what's the number going to be there? 6. And that would be the correct answer over there. By the way, the index J could be changed to a different letter. They use the letter N over here. Do I have the same thing? Yes, I do. I just used a J. They used an N. Same story. All right, let's do this one over here. And a little more complicated. It's a Math 120 question. And they say the sine of alpha is minus 5/13 and the cosine of beta is 3/5. And they said they're in the fourth quadrant. So I want to visualize that. So I'm in the fourth quadrant. And that's alpha. And I'm not saying I'm doing the best picture in the world, but I kind of know something about this picture. And I know that there's a triangle there, might form, with a radius of 13 or hypotenuse of 13. And this side's 5. I'm just using the triangle, by the way. And I want to figure out this side over here. And how do we do that? 13 squared, which is 169, equals 5 squared. That's 25, plus, I don't know, it's some number over here, right? Some number being squared. So what do you get over there? 169, that's 144, right? And I know that looking at the picture that this number over here is 12, all right? So I know the cosine of alpha is going to be 12/13 now. All right, now we're going to do the next one. I'm going to get rid of my baby work. I'll do the beta. And it's also in the fourth quadrant, right? I'll put this over here. Again, I'm not saying it's a great looking picture, but I know the ratio here. Let's see, 3 and 5. And this would be 4 over here. Now, someone says, you know, why did you put minus 4 over there? It's a triangle. It's really 4. But I know the y-coordinate's negative. So let's write this over here. It is sine of beta is minus 4/5. All right? Now, what's our question? What's the sign of alpha minus beta? This is a sum formula. I'll write it down for you. Sine alpha cosine beta minus sine beta cosine alpha. Let's put a work down. What's sine alpha? Minus 5/13. What's cosine beta? 3/5. Minus, what's the sine of beta is minus 4/5. We have an etch key to check later, okay? And then what do we get over here? The cosine of alpha is 12/13. Well, it looks pretty easy because the common denominator is 5 times 13, which is 65. That's going to be minus 15, and it's going to be plus 48. Mistakes can happen. And let's see what you get over there. It looks like 33, right? Got an answer over here. All right. Oh, cosine alpha minus beta. What's it going to be? Cosine alpha, cosine beta, plus sine alpha, sine beta. We're still in Math 120, by the way. Now, again, someone says, I don't remember what cosine alpha or beta is. We write them down for a reason, by the way. And you want to look at that. No, cosine's 12/13 and 3/5. I'll put that down for you. Plus, I got to do sine alpha, sine beta, and that's minus 5/13 minus 4/5. Well, this is convenient. Common denominator 65. And what do you get there? 36 plus 20. And 36 and 20 is 56 over 65. Mistakes happen. That's why we give you a K. Now, what's nice about this one over here, I don't need a formula for it. And why is that? This is sine alpha minus beta over cosine alpha minus beta. Did we compute those? We did. So what do we got? We got 33/65 and 56/65. What does this give me? 33 over 56. All right, let's see how we did. And I see that right over there. A little more complicated. And someone says, why is it more complicated? It's a half angle formula. So I'm going to point out, before I do anything, I want to point out that the alpha, and this is really important you know this, the alpha is between 270 degrees and 360 degrees. And someone says, how do you know that? Well, you go back and you read the original problem. It's in the fourth quadrant. Then my story is, what's half of that? Well, I'll write that down for you. And what do you get over there? Well, it's really not that bad. It's 180 degrees. This is alpha over 2 now. And 270 divided by 2 is 135, right? Now, someone says, why do you need to do that? I need to know the sign, that's S-I-G-N, of the sine function. And the sine function between 135 and 180 is a positive number. And I would need to know the half angle formula. And what's that going to be? 1 minus cosine of alpha over 2. You would need to know that formula. If you need to go back and review that, that's fine, by the way. Now, certainly sometimes I can't remember things, I have to derive them, and I don't mind deriving things. I'm just saying I kind of remembered that today. Now the question comes, do you remember what cosine alpha is? And I go back. I'm not trying to memorize things. What's cosine of alpha? Well, 12/13. Let me put that down for you. And, whoops. It's going to be the root of 1 plus 12/13 over 2. I need to do some arithmetic now because it looks really nasty. And I'll write this over here. I'm going to multiply top line by 13. And what do you get? You get 13 plus 12. And 2 times 13 is 26, right? So what do you get over here? Well, let's see. 13 and 12 is 25, isn't it? Oh, I'm sorry. I made a mistake in the arithmetic. I just noticed that. That's a minus sign. My apologies. I got to get my eraser out again. Erase this business here. Sorry about that. Well, let's see, 13 minus 12 is 1, so it's 1 over root 26. Now, I don't mind the way that's written, but some people have to rewrite that, and certainly I don't want to rewrite it, but you could do this too. That's what your Math 100 teachers would make you do. I just think it looks awful. But anyway, that's the answer. Now let's do the cosine of alpha over 2. And again, I want to remind you that the angle, this is where the angle is, and the cosine on that interval is negative. So I know what the answer is negative, and I'll write this one over here. And this will be 1 plus cosine alpha over 2. What's going to be minus? And let's see, 1 plus 12/13. I can remember that. If you can't, it's written down in the beginning, over 2. This is minus. I'm going to multiply top mod by 13. And that would be what? Let's write that down. That's going to be 13 plus 12 over 26. Now let's keep doing that. 13 plus 12 is 25. The square root of 25 is 5. And you get root 26 in the bottom. I got this over here. Now here comes another one, and it's crazy looking, but what is this thing over here? It's really the sine of alpha over 2 divided by the cosine of alpha over 2. And do I know the sine of alpha over 2? Well, not that I can remember it, but I kind of can look back on my notes. It's 1 over root 26. And what's the cosine of alpha over 2? It's minus 5 over root 26. What do you go there? Minus 1/5. Very simple number, by the way. Let's take a look at our key. I see that. All right? So let's take a look at this one over here. I kind of read it to you. It says if secant of theta equals 7, and you're between 270 and 360 degrees, find the following. Oh, I can do that. And I'll tell you why I can do that. I'm going to draw a picture for you. And I know I'm in the fourth quadrant, by the way. And I'm not drawing an accurate picture, but enough to get me going. And so the secant of theta is equal to 7. That means the cosine of theta is going to be 1 over 7. Now, what does that mean? I got 1 there, 7 there. And I'll put this over here, which I know is a negative number now. 7 squared is 49. And that would be 1, because 1 squared is 1, plus a question squared. And that's going to be 48. And a question squared. So I think I can do that. And that's going to be minus the square root of 48 is going to be 4 root 3s. All right? Again, if you square that number, you get 16 times 3, which is 48. So I think I can start writing things down now. And they want the sine of theta, and that's really easy to put down now. What's that going to be? Well, it's going to be minus 4, and you need to know the definition of the functions, by the way, root 3 over 7. Let's see if we got that right. Wow. What's next one? The cosine. Well, that's already written down for me. It's 1/7. I got that one right. What's next one? The tangent of theta. Well, the tangent of theta, I don't have that written down. I'll write it down for you. What's that going to be? Well, I'm looking at it. It's going to be minus 4 root 3 over 1, which is minus 4 root 3. Let's go over here and see if we got that right. Yep. What's a cotangent? It's a reciprocal. What's the reciprocal of that number? It would be, let's see, 1 over minus 4 root 3. Again, I would say that's inappropriately written. I'd write this as minus 1 over 4 root 3 or minus 1 over 4 root 3. I'd say this answer and that answer are acceptable. That's the answer they have over here. What's the cosecant? A little more complicated. What is this going to be? The cosecant is the reciprocal of the sine. So it's 7 over minus 4 root 3. And again, write this as either minus 7 over 4 root 3 or minus the ratio 7 over 4 root 3. Both of these answers are completely acceptable. And that's written over here. All right, so it says write the inequality in the form. Again, this is an absolute value inequality. This is Math 119. Let me see if I wrote down Math 120 for this one, or I didn't. I'll put this down. This is Math 120. The reason I mentioned that to you, you may have to go back and review it, all right? Again, still Math 120. Yeah, we did that. It's worked, though, isn't it? So what's this one over here? It's going to be 2x plus 2 is between 4 and minus 4. I'm going to divide all sides by 2, and you get minus 2, x plus 1 less than 2. And I'm going to subtract 1 from all sides, minus 3, x, and 1. All right? If you want to put the intervals down, the intervals would look like minus 3 to 1. All right, but they asked for this notation here. I did that. All right, this one says let blah, 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 blah. What's a domain of f? Well, a domain of f is all real numbers. Why is that? It's a rational function, but the bottom never becomes 0, so it's all real numbers. Let's see how we did. Wow, all real numbers. What's the other question, though? What's the range of it? Far more difficult to do. It really is. So I'm going to claim over here is that if you thought about it, you're looking at this over here. And I want to point out, just kind of thinking through it, I'm going to say at 0, right, when x is 0 would be the number 1. I'll put that down for you. So when x is 0, you get the number 1. Now what happens to this on the bottom? It grows. So it's going to be asymptotic with 0 in both directions, by the way. Now I understand it's tough to connect this together, but I'm going to maybe say something like this over here. And I'm not saying it's the easiest thing in the world to do, but maybe something like that, a bell-shaped curve, so to speak. What's the range of that? Well, the range of that looks like it goes from 0 all the way up to 1, and it touches it. So 0 to 1. That's written over here. So this one says, write an expression for the nth term. Well, someone says, where are you going to start? I'll start at 1. So A1 is equal to 2. A2 is equal to 1. A3 is equal to 8/9. A4 is equal to 32 over 25. Well, I'll be honest with you. Whoops, I'm sorry about that. I made a mistake already. I gotta erase this over here. Let's see. A4 is 1, and then A5 is 32 over 25. Well, I got a problem immediately, and what I notice is that not everything's written as a fraction. And this is written as a fraction, 32 over 25. This is written as 1 over 1. This is written as 8 over 9. And this is written as 1 over 1. And this would be 2 over 1. And it looks crazy. It really does. But I'm going to look at those two fractions and see if there's anything I can get out of those things that might be helpful. So I'm going to look at the top first. And I'm saying that, looking at this thing, it looks like a power of 2. So I can say this looks like, 2 cubed. I'm just doing the top first. And this looks like 2 to the what? Let's see, it looks like 5, doesn't it? So if this is true, this would be 2 to the 4. This would be 2 to the 2. And this would be 2 to the 1. Well, that certainly works out for some of them, but not all of them, right? So let's look at the bottom. And I'm seeing 9 and 25. I'll point out what I mean by that. I'm seeing the 9 and 25. So I'm looking at it. What could that be? I'm going to say it looks like 3 squared. And this looks like 5 squared. What would this be? 4 squared. We got to check this out, though. What would this be? Let's see. That would be 2 squared, right? And this would be 1 squared. Well, let's see if we get what we want. 2 divided by 1 is 2. 2 squared divided by 2 squared is 1. Boy, these are working out nicely. This one's going to be 8/9. That works out nicely. This one's going to be 16, and 4 squared is 16. This is equal to 1. That worked out nicely. And this would be 32 over 25, and that works out nicely. I think I'm ready to write it down now. What's AN? Well, let's take a look at that. It looks like 2 to the nth power. And what goes on bottom? Looks like n squared. We're done. Boy, this is deja vu, isn't it? Let f of x equal this, and g of x equal that. What's g of 2? Got to write that down. What's g of 2? Well, I can write that down. F of 2 plus, let's say h is 0.01, right? Minus f of 2 all over 0.0. I'm sorry, not 0.01. I'm sorry about that. I did it again, didn't I? 0.1. I gotta be honest, I don't think I want to do that computation. I don't. So what I'm going to do is I'm going to rethink it, and I want to say that I'm going to rethink the problem. And the way I'm going to do that is I'm just going to do the difference quotient as written. So g of x is equal to, well, the x being 2 is really not that bad. It's the h that's killing me. So I'm going to do that for you. I'm going to do g of 2, but I'm not going to put the h down as a number. I'll do that later. It's just too much for me. I'm going to get here f of 2 plus h minus f of 2 over h. And I'm going to do that for you now. What's g of 2? Well, that's a cubic, right? So you can get 8 plus, I'm using the binomial theorem. This is math 120 now, and it's math 119. You did difference question 119. Binomial theorem was in math 120. The next going to be 4 times 3, which is 12, h. And then it's going to be what? 3 times 2, 6h squared, plus h cubed. And f of 2 is just going to be 8 all over h. Well, let's write this down. What's g of 2? Well, that's going to be 12h squared. I'm sorry, 12h. I'm sorry about that. Divide by h, which is 12, plus 6h. Sorry, this is h cubed over here, plus h squared. All right, I got some work now to do. By the way, it's easier for me to do this than it was to do the other problem, and that's why I selected to do that. And let's take a look, and I'll write this down now. So g of 2, when h is 0.1, I can do that. That's 12 plus, well, 6 times 0.1 is 0.6, right? And if you square 0.1, that's 1/10, that's 1/100, so that's 0.01. So what do you get over there? 12.61. Okay? I think that's all they asked for. Let's see, what is g of 2 when h is 0.1? I did that. What is g of x? They did ask for that when h is 0.1. Oh, I got to write that down. I didn't do that. So let's do that, g of x. And what's that going to be? Well, it's going to be x plus h now. Minus f of x over h. Let's write this down for you. So g of x is going to be x cubed plus, let's see, 3x squared. Let's see, plus 3xh squared plus h cubed minus g of x, which is x cubed. Sorry about jamming this in for you, over h. And it works out pretty nice, by the way. G of x equals 3x squared, h. Then what do you get? Plus 3x. Oh, you know what? Let's divide through by h. Sorry about that. Make it easy, right? So 3x squared plus 3xh plus h squared. All right? And then what do they want? You know, what does it equal at 0.1? So let's write this down. What does g of x equal when h is equal to 0.1? So you get 3x squared. We'll look at the key later. Plus 0.3 x, and that would be 0.01 now. Let's see if I got that right. That's right over here. And I got 3x squared plus point. Yeah, we did okay. All right. Now, by the way, the way your teachers in math, this is math 120 now, did this problem may be different than the way I'm doing it. But, you know, the bottom line is we can't disagree on the answer in the end. So let me write this one down for you. I'm going to say x equals 0.54. I'm going to multiply both sides by 100. That'll be 54.54 forever. I'm going to subtract, and what do you get? 99x equals 54. And now I'm going to divide both sides by 99. So you get 54 over 99. And by the way, I don't mind the answer. This is a good answer. This is a rational number, by the way. That's what they wanted me to get. They're fractions. They said that. And I'm going to say I'm also going to reduce it. And so how would you reduce that? It looks like 9 goes into those numbers. 9 goes into 54 6 times, and it goes into 99 11 times. So I say 6 11s looks better. Let me do the other one, which is this over here. And this is going to be x equals 0. What's that number? 4. And what's repeating is a 3, 3. So the first thing I would do is I'd multiply by 10x. And you would get 4.33. The next thing I would do, I'd multiply by 10 again. So 100x. What does that give you? 43.33 repeated. And now I'm going to subtract. And what do you get? Let's write this over here. 100x minus 10x is 90x. And 43.3333 forever, subtract away 4 is going to be 39. What do you get over here? X equals 39 over 90. Looks like it's divisible by 3, right? So 13 and 30. 13 over 30. Let's see how we did. Wow, miracle. Sketch one period of the graph. And again, the way you've done this in class might be different than the way other people do it. I noticed that they want one cycle down, and let's go through this. I like to put a beginning down, and the beginning is 1 pi x. Again, you may do things differently, but the outcomes will be the same. I like to put an end down for this. And for the sine function begins at 0, and it ends its cycle anyway at 2 pi. Let's write this down. So pi x equals minus 2 pi, and x would equal what? Minus 2, right? And where does it end? Let's write this down. So let's see. Pi x equals 0, x equals 0. All right, got my begin end. I'm on my table down now. X and y. And my begin is at minus 2. And I know the sine function has 5 characteristic points on it. So I got 3 in the middle. 1, 2, 3. And the last one's going to be 0. Well, if I'm looking at that, what's the dead center between that and minus 1? And what's the dead center between minus 2 and minus 1? That's minus 3 halves. Whoops. Got to get my eraser. Minus 3 halves. And what's between minus 1 and 0? Minus 1 half. Let's take a look. I'm plugging it in. And I'm plugging it into this over here. And it should be relatively simple. Plug in minus 2, you get sine of 0. Sine of 0 is 0, and 0 plus 1 is 1. Minus 3s, when you plugged it in, you would get pi over 2. The sine of pi over 2 is 1, and 1 plus 1 is 2. If it did minus 1, I'd get pi. The sine of pi is 0. 0 plus 1 is 1. We'll check the points later. Minus 1 half would give you 3 pi over 2. That's minus 1, and minus 1 plus 1 is 0. Now, if I put 0 in, what do I get? That'll be 2 pi. The sine of 2 pi is 0, and 0 plus 1 is 1. So I get the points minus 2, 1. I got the point minus 3 halves, 2. Got the point minus 1, 1. Minus 1 half, 0, and 0, 1. I'm going to plot them. And how do you plot that? It's already done for me, but let's go through that. Minus 2, 1. That's right here. Whoops, sorry about that. Minus 3 halves, 2. That's right there. Minus 1, 1. That's right there. Exactly what we expected, by the way. Minus 1 half, 0, and then 1, 0. And then you connect the dots together. And this is one cycle. They said one cycle? One cycle. That's all I'm going to give them. Find the equation of a circle with center 2, 2. What would that look like? It would look like this. X minus 2 squared plus y minus 2 squared is equal to some number squared, r squared, the radius squared. Well, what do they say? They say when r is 2. Well, if r is 2, what do I get? I would get x minus 2 squared plus y minus 2 squared is equal to 4. Check the key. I'm seeing it. Let's do the next one. Oh, this one's much more difficult. This one says it passes through the point 1 minus 1. So what's going to be x minus 2 squared plus y minus 2 squared is equal to r squared. So what I'm going to do, I'm going to plug it in. So I'm going to plug the point into that equation and figure out what r squared is. And what's 1 minus 2 is minus 1. Minus 1 squared is 1. Plus minus 1 minus 2 is minus 3. And minus 3 squared is 9. So r squared is actually equal to 10. Let's write that down. X minus 2 squared plus y minus 2 squared is equal to 10. We're done with that. By the way, this is math 100. All right? This is math, whoops, sorry about that. 15 is math 120. This is math 120. I think I forgot to write that down, by the way. Yeah, I think I'm okay. Again, if you have questions that are outstanding, you come by during office hours. I'd be more than happy to answer questions for you. Let's look at number 17. Number 17 is a rational function. This comes from Math 119. Let's take a look. And how do you get an x-intercept? I guess I got to factor these guys, don't I? Let's put this over here. You would get x squared. That would be x plus 2 over x squared plus 1. So it's really not bad. I mean, when does this become equal to 0? Well, when x is 0, and the other one is when x is minus 2. I'm seeing those right over there. What's the y-intercept? That just couldn't get any easier. What's that going to be? Set x to be 0. Well, if you set x to be 0, the y would be 0. Right? That's done. Super simple. Find the linear asymptotes of the equation. Well, again, you may not be able to recall this, but in Math 119, they told you if the degree of the denominator is 1 less than the numerator, do a long division. So I want to go through the long division for you. And this will give me an oblique asymptote. All right? And by the way, it's the only asymptote I'm going to see in this problem. The bottom is never 0. All right? So let's do the oblique. All right? How do I do that? Long division. So I'll write this down for you. X squared plus 1 is being divided into x cubed plus 2x squared. One thing at a time. Well, it's going to be x times x squared would be x cubed plus x. I didn't go too fast with that. I got to subtract, right? So what do you get? 2x squared minus x. What am I going to do now? Well, I'm going to say plus 2. What do you get? 2x squared plus 2. Well, it's going to get tough, isn't it? And what do you get there? Well, you would get minus 2 minus x. So I know my oblique asymptote is simply just x plus 2. So the linear asymptote, there's only one of them, is y equals x plus 2. Let's see if they got that. We got that. By the way, they call it a slant. I called it oblique. It's the same meaning. All right? Graph it using sign analysis. I'm going to cut to the chase, by the way. I'm going to go over here. I want to point out what this line is over here. It's the asymptote. Y equals, and again, if you can't remember, you go back and look. It's x plus 2. How do you graph that? You just get 2 points. One easy point there would be minus 2 for x, would be 0 for y. Another one, when x is 0, y would be 2. So this is going to be the point 0, 2. And this point in that dashed line, by the way, is going to be minus 2 comma 0. Then you just draw the dashed line through it. All you have to do. All right, I'll put that down for you. And yes, I know it's there already. All right, let's keep going. The other thing I'd put down is the points I got. And I got a bunch of points. I got 0, 0. That's one point I got, if you recall. And what's the other point I got? You may not be able to recall, but I think I can recall because I wrote it down. It's minus 2, 0, right? Back over here. And minus 2, 0. Right over there. Minus 2, 0. Right to that asymptote. Now they say do sign analysis, right? And someone says, how do you do that? Well, let's go back over here. And I'm going to do sign analysis on this factored form. It looks pretty easy to me. I'll tell you why. It becomes 0 at only 2 places. At 0 and at minus 2. Well, to the right of 0, like pick 5, it's always positive. Between 0 and minus 2, pick minus 1. And what would you get? Let's see. Minus 1 would give you, positive. Look at that. All right, minus 1. Let me just check that. Yeah, positive. Now let me go to the left of minus 2. What would that give me? Like minus 3. Well, that would be negative then, right? What do I do now? Well, I'm looking at the behavior. So I know over here to the right of 0 it's positive and it's going towards that asymptote. Now granted, I know there's a connection between these two, but it's positive. Now what do I know between minus 2 and 0? I know it's positive. So I'm going to say something like this over here. Yes, I'm looking at the picture. I know that. And below the minus 2, it's negative, which means it's asymptotic with this line over here. That's not bad. Okay, these require the use of a calculator. I want to point out the symbol we're using, and you got to use a calculator. And over here, you must be in degree mode. I don't think you should be using anything, a calculator, to do that computation. Could you approximate it? Yeah, but you're not going to get this level of approximation. Same thing for this guy over here. But I want to point out, this you need to be in Radian mode. Now let's say you don't have to use your calculator, even after taking Math 120. Come by during office hours, and we can help you with your calculator. Now over here, you need to be in Radian mode. And again, if you can't get these numbers, you come by during office hours, and we'll help you with it. All right, Radian mode in your calculator. This one over here, Radian mode. This one over here, Radian mode. Again, if you can't use your calculator, come by and see me. Radian mode. By the way, either mode, if you're in degree mode, it will return degrees. If you're in radian mode, it will return a radian. All right, make sure you can use a calculator. So in degree mode, you would get this number. If you were in radian mode, you'd get this number. Likewise, over here, what mode you're in. If you were in radian mode, you'd return this number. If you were in degree mode, it would return this number. This one over here, again, if you're in radian mode, it would return this number. If you're in degree mode, it would return this number. All right, let's look at this one over here. It says, find the first 5 terms. And I got to be honest with you, I think it would be hard not to get the first term. It's 15. Now I'll put the second term down. And I'm going to use this formula here to do it. What's that going to be? That's going to be 3 times A1 minus 2. I think I can do that. 3 times 15 is 45. 45 minus 2 is 43. Let's put down A3 now. That's going to be 3 times A2 minus 2. Well, it's more difficult. 3 times 43 is 129 minus 2, which is 127. Let's do A4. That's going to be 3 times A3 minus 2. And again, this is 127. Well, 3 times 127 is 381 minus 2, which is equal to 379. All right, they get more difficult, though, aren't they? Let's put down A5. That's going to be 3 times A4 minus 2. What's A4? It's 379. Well, that's going to be, let me write this down for you. It's 900, and 3 times 70 is 210, and 3 times 9 is 27. 7, 3, 11. So 1137 minus 2. 1135. Right there. We did okay. This one says factor. I noticed there's a footnote over there, and maybe it's useful, maybe not. It says previous problem may be helpful. I don't know about that. I don't remember seeing a previous problem like that. Let's take a look. Did they give me a prior problem like that? I don't think so. So maybe it's so long I can't remember. I'm going to use the rational root theorem, though, to figure it out. I'm going to use the rational root theorem to figure it out. I'm going to say the rational roots of this. Rational roots would be plus or minus. Well, the factors of 3 divided by the factors of 2. So I'm going to say like 1 and 3 would be good candidates. Now, there are ones after that, but I don't want to go there yet. All right? So I'm going to try 1. Right? Does f of 1 give me 0? I don't know. Let's take a look. You get 2 minus 5 minus 4 plus 3. Let's see. That does not give me 0. All right, let's try f of minus 1. Now, if that doesn't work, I got to go to 3. And I get really tough. Let's do f of minus 1. It's more difficult. So you get minus 2 minus 5 plus 4 plus 3. And lo and behold, that gives me 0. So now I know there's a root. The root is minus 1. So if the root's -1, the factor would be is x plus 1. Sorry about that. What I don't know is I don't know what happens now. And I got to do it for you. So I'm going to do this for you. It's x plus 1. And that's going to be 2x cubed. I'm doing long division, by the way. Minus 5x squared minus 4x plus 3. So it's going to be 2x squared. That would give me 2x cubed plus 2x squared. That's minus 7x squared minus 4x plus 3 minus 7x squared. Let's see, minus 7x. That will be 3x plus 3, and lo and behold, plus 3 at the end. That looks pretty good. I'm going to look at that. I'll write that down over here. So it's going to be 2x squared minus 7x plus 3. Now, this guy over here is called a depressed quadratic. Not because it's sad, because I started a cube. Now I'm down to factoring a quadratic, and I think I can handle it, including it to go to quadratic form, which I hope I don't have to do. So I'm going to give it a try. I'm going to say 2x and x. And I'm going to say 3 and 1. Minus, minus. Let's see if it works. You get 2x squared. Yep, that worked. Minus 6 minus 1 is minus 7. Yeah, it works beautifully. So what does it factor? It's now factored. It's the factorization. And this factorization is listed right over here for you. The complete factorization. All right, I'm going to call it quits now. And I'm just going to break this into pieces. I'm going to come back and start 21 later. Thank you.